Welcome to The Explainer. Today, we're talking about a really critical shift in AI. It's about moving these models from just being thinkers to actually being doers. We're going on a journey from the brain to the hands. And trust me, it changes absolutely everything.
All right, so let's just dive right in. We've all seen what these large language models can do, right? They can write poetry, they can debug code, they can even try to explain quantum physics. But there is a huge gap between generating some text and taking a real useful action in the world, like actually booking that flight for you. And that's the real challenge we need to solve.
So for a long time, the whole conversation was about prompt engineering, the art of writing that one perfect instruction. But here's the thing, the real breakthrough isn't just a better prompt, it's about building an entire system around the AI. And this is a much bigger, broader discipline called context engineering. It's all about managing the AI's entire world, its whole reality, over time.
So what is context, really? Well, it's basically everything the model can see when it makes a decision. And it is so much more than just your prompt. It's the conversation history, it's the documents it can look up, the tools it's allowed to use, everything. Engineering that context, that's how we get reliable, consistent, and genuinely useful results.
Okay, to really get a handle on this, let's use a simple analogy. I want you to imagine a standard large language model as this brilliant, incredible brain. The only catch? It's completely isolated. Literally, a brain in a jar.
This brain, it has amazing reasoning skills, but it has zero memory of the conversation you had 5 minutes ago. It can't look up today's stock prices or check the weather outside, and it definitely can't send an email or update a database for you. So it's super smart, but it's completely stuck.
So how do we make this brain useful? Well, the very first step, the first piece of the puzzle, is to give it a memory. We need to give it a way to remember what's happened and to access knowledge from the outside world.
And just like us humans, this AI brain needs different kinds of memory. You've got procedural memory, that's just its basic instructions on how to behave. Then there's episodic memory, which is basically what just happened in this conversation. And then the really important one, declarative memory. That's its connection to a huge library of external facts and documents.
Now, the main technique for this declarative memory is something called RAG, which stands for Retrieval-Augmented Generation. And what's so crucial to understand here is that this isn't about retraining the model. It's a system that, in real time, goes out, finds the most relevant information from a knowledge base, and then injects it directly into the AI's context right when it needs.
So how does this actually work? Well, first we take these big documents and break them down into small, manageable chunks. Then we convert those chunks into a numerical format the AI can actually understand, these things called vectors. Now, when you ask a question, the system finds the most relevant pieces and just feeds them to the AI along with your prompt. This is what keeps the AI's response grounded in verifiable facts.
Okay, so our brain can now remember stuff and look up facts. That's a huge step forward. But it's still just talking, right? It can't actually do anything yet. For that, we have to give it hands. Now, these hands, of course, they aren't physical. They are the digital tools, the APIs, that let an AI agent go beyond just having a conversation and actually start taking action for us, interacting with software, databases, and all kinds of other systems.
A really key technical standard that helps make all of this possible is the Model Context Protocol, or MCP. Honestly, the best way to think about it is like a universal adapter. It creates a standardized way for the AI to securely plug into all sorts of different systems and use them as its tools.
So what can these hands actually do? Well, pretty much anything a digital worker could. It can go fetch live sales data, you can create a task in Jira, send a Slack notification, or update a customer record in Salesforce. This is the moment the AI transforms from just a chatbot into a true, capable assistant. Okay, so we've got a brain for reasoning, we've got memory for knowledge, and now we have hands for taking action. Let's put it all together and see how these pieces work together in this continuous, intelligent loop. This right here, this is the core operating system for a modern AI agent. It's this constant cycle. First, it interprets the goal. Then it creates a plan. It uses a tool to act. Then it observes the result of that action. And finally, it updates its context and just repeats the whole process. It just keeps looping and looping until the job is done.
But what happens when tasks get really, really complex? I'm talking about things with dozens of steps across multiple systems that could take hours to finish. At that point, you need more than just a single agent. You need an orchestra conductor.
And this is where an orchestration layer comes in.
You can think of it as the agent's central nervous system, or maybe it's project manager. It's the part that handles all the messy details, managing complex logic, retrying steps that fail, and making sure actions happen in the right sequence, reliably over a long time.
A tool like N8N is a perfect example of this. It doesn't just manage one agent's tasks, it can actually coordinate a whole team of specialized agents. Just imagine a research agent that finds some data and then hands it off to an analyst agent, and that agent then passes its findings to a writer agent to create a summary. The orchestrator is the thing that makes all that teamwork possible.
And there you have it. That is the complete architecture for a competent digital worker. You've got the LLM as the brain, RAG providing the memory, tools acting as the hands, and an orchestrator serving us the nervous system that wires it all together. This is how you build something that is truly useful, reliable, and actionable.
You know, building one of these isn't magic. It's a real engineering discipline. You have to define the job clearly, write good instructions, curate its knowledge sources, and give it the right tools. And maybe most importantly, you have to test and evaluate it relentlessly. You really start to treat the agent's context like a product, one that needs careful design, quality assurance, and constant improvement. And this takes us way beyond the technical how and right into the much more creative what. We now have the architecture to build these really sophisticated digital workers that are capable of complex tasks. So the real question for all of us now is, what problems should we solve with them? What are we going to build next?